we're going to begin with simplifying rational functions. And rational functions take on the form where you have some quotient here. And recall, quotient just involves division. And the quotient is going to be a polynomial, r of x, that takes on the division of another polynomial, p of x, divided by some polynomial, q of x. So when we begin to simplify these rational functions, it's important that we recognize that we cannot have our q of x, which is our denominator, be equal to 0. That would lead to being undefined, which we know we cannot have. So when we begin working with these, we want to make sure that we first state the restrictions to the domain of our function. Remember, the domain refers to all the x's that your function can take on. So the domain becomes restricted when we worked with rational functions. So I've got this first one here. I've got that g of x is 24x to the 7th divided by 6x to the 5th. Now, right off the bat, it's very evident to me what x in the denominator cannot be. And that is, we cannot have 0 in the denominator. Now, how would that happen with a 6x to the 5th? Well, this is what we actually do. We actually take that denominator, we set it equal to 0, and we solve for x, because that will tell me what value of x would make all of this 0. So to get x by itself, I'll divide by 6, divide by 6. That tells me x to the 5th equals 0. We would then take the 5th root of x, and on both sides. The 5th root of x gives me x, but the 5th root of 0 is just 0. So it's when x is 0 that g of x would be have a restriction. It's when it would make our denominator undefined. So what we have here is the restriction is that x cannot equal 0. So x is not allowed to equal 0. I'm actually going to put it over here. And we do want to go ahead and simplify this function g of x just for the sake of good practice. We know that this actually simplifies to 4x squared. 6 divides into 24 4 times, and x to the 5th divides into x to the 7th, x squared times. So the domain is actually all real numbers except for 0, not including 0, we cannot. But any other numbers are fair game. Now, we move on to example 2. And before we get rolling with this one, we need to first see if we can actually simplify or clean things up just a bit. What I mean is let's rewrite this numerator and this denominator. Here's how I'm going to do it. Now, I know that I can actually take this numerator, the 2x squared plus 5x minus 3, and I can perform that diamond method, that AC method. I'm going to have to use factor by grouping because my leading coefficient is not 1. So I'll get a -6 and a 5. I need those two numbers that multiply to give me -6 and add to give me -5. And it looks like I'm actually going to get, let's see, am I going to get -6 and 1? I could do -1 and 6. That would work. -1 plus 6 is 5, and -1 times 6 is 6. So we now have a 2x squared plus 5x, minus x minus plus 6x. Those are coming from my magic numbers here. And then we still have our -3. We factor by group. What's common in group 1 is going to be just an x. So I factor it out and I'm left with 2x minus 1. Bring down your sign. factor out what's common, the greatest common, I should say, which is 3. You're left with a 2x minus 1. Parentheses match. We know that we've successfully factored this into x plus 3 times 2x minus 1. Now, that numerator has now been rewritten to become x plus 3 over 2x minus 1. So here's my numerator, x plus 3 times 2x minus 1. What about the denominator? Can I rewrite my denominator in any way? Well, let's see. I know that my denominator cannot equal 0. I know that any value of the denominator being equal to 0 would cause it to be undefined, which is an issue. So let's set the denominator equal to 0 and solve for x. And I'm actually going to do that over here. So for my denominator, I have a 4x squared minus 1 equal to 0. And I want to see when this would be equal to, how I can solve for x, I should say. So I add 1 to both sides, divide by 4, and I get x squared equals 1/4. Taking the square root of both sides to solve for x means that x equals a 1. Square root of 1 is just 1. And the square root of 4 is 2. However, it's important to note that what we actually have is plus and minus 2, because we know that both 1/2 squared and -1/2 squared produce 1/4. So we actually have to take the plus and the minus. So we write this as plus minus. So we now have found that when x equals +1/2 and -1/2, that would lead us to have a 0 in the denominator. So here's what we know. We know that x cannot be 1/2, nor can it be 1/2. So we're going to write that here. X cannot equal -1/2 or +1/2. That's our restriction. Now, the last thing left to do is to actually go ahead and factor that denominator so that I can cancel some terms out if there's anything that'll allow me to cancel. In other words, simplify. So it may not be that obvious, but this denominator here is actually a difference of squares. Yeah, we can actually write this as 2x plus 1, 2x minus 1. What will happen is when we FOIL this back out, we will get back what we started with, which is the 4x squared minus 1. So I'm going to write that down here for my denominator, 2x plus 1, 2x minus 1. And we could have noted that prior to finding what the restriction was, but it's okay. It doesn't matter which way, as long as we know, hey, here's the simplified version of my function. And we note that although this is simplified, and although I can cancel here a factor of 2x minus 1, my result will be x plus 3 over 2x plus 1. So we get this as our result. This is what f of x equals, but we still have this restriction on our domain that x cannot equal -1/2 and +1/2.